Oh, okay, so we didn't have enough time to finish this yesterday, so I'm going to do this for you um, as quickly as I can so you can actually see how it's done. Um, you needed to find out or do the proof of the tangent of the half angle is equal to the sine of theta over 1 plus the cosine of theta. And so I'm going to start this proof by just dealing with stuff on this side. So I'm going to rewrite the tangent of the half angle as the sine of the half angle over the cosine of the half angle. And I believe yesterday I had already proved to you what each one of these were. So the sine of the half angle is equal to the square root of 1 minus cosine theta over 2 divided by the square root of 1 plus cosine, and I'll put alpha here, alpha over 2. So I just used the definition for sine and cosine of the half angle. Now, because there is a 2 there, and there's a 2 there, those two 2's cancel. So you're left with the square root of 1 minus cosine theta over the square root of 1 plus cosine theta. So I'll put alpha there and alpha there, just so I keep it straight. This is a radical. So in order to remove the radical, we have to multiply by what's called the conjugate. The conjugate is the exact same thing except for the sign in the middle changes. And I have to multiply by a form of 1, so I'm going to multiply both the top and the bottom by the conjugate. So I'm going to multiply this by 1 minus cosine alpha, and I'll multiply this by the square root of 1 minus cosine alpha. And so on the top, I get the square root of 1 minus cosine alpha squared, because I have 2 of them. And this bottom is called the difference of 2 squares. So you end up with the square root of 1 minus cosine alpha squared. If you FOIL this out, and you want to do that to show all the steps, if you FOIL this out, you will get this. Okay? So now this is one of our trig identities. If you remember that 1 minus cosine squared is equal to sine squared, then I can substitute the sine squared in for this whole thing, because those two things are equal to one another. So let's do that. So I have the square root of 1 minus cosine alpha squared over the square root of 1, put that in parentheses, of sine squared alpha. If you take the square root of a square, they just both cancel one another. And I also have another square root of a square on the top. So that means that this is equal to 1 minus cosine alpha over sine alpha. So I need to get the sine on the top. And I think this is one of the trig proofs that you actually had. This was the second one that you wrote for me. So we got to that one. So now I'm going to what would be the easiest thing to do? I'm going to multiply this one by the conjugate of that. So I'm going to take the top and the bottom and I'm going to multiply it by 1 plus cosine squared. And this will be 1 plus cosine squared. Let's see what happens when I do that. So on the top I get, sorry, that's not squared. That's just 1 plus cosine. So that's a form of 1. So on the top I get 1 minus cosine squared alpha. And on the bottom I get sine plus sine cosine alpha. Well, the top then becomes sine squared and then the bottom will become sine theta plus sine, sorry, I'm missing the sine and alphas. Cosine alpha. So now I'm going to factor the bottom. So I have sine squared alpha on the top. Oh, I didn't even have to do that. And then I have sine alpha on the bottom times 1 plus cosine alpha on the bottom. I have a power of 2 up there. I have a power of 1 up there. So this cancels that power. So now I actually have my identity where it's sine of alpha over 1 plus cosine alpha. And so that's equal to the tangent of the half angle alpha. So you see, as part of the proof, you got both of those proofs that he wanted you to do. I hope that was helpful. If you have any other questions, I guess you can call me.